All right, so if we really need 21, the issue is for you to stand up, right? This part A is just estimation. So for example, I'll estimate for myself. My mass is 100 kilograms. And when I sit down to when I stand up, how much does my center of gravity go up? How much do I raise it? I would say about 20 centimeters. So if that's how much it takes, like if that's how far I change my center of gravity, then the energy required is just the PEG. So the PEGH, and that's 100 kilograms, whatever, 10, 2. Because that's about, I'm just guessing how much does my center raise? Now, I guess from down here, if I went down here, it's about even with the top of the desk to up here. Okay, maybe about 30 centimeters. Because your mass is located in your center of gravity. Like, not really, obviously. Your mass is distributed through your body. But for the effect of doing these questions, like when we did a force diagram, where did we draw the arrows from? The center, the middle, because we always want to talk about forces acting on the center of mass. Because remember, if you get a force that's not on the center of mass, what does that cause? If I apply a force to you that's not on your center of balance, what does it cause? Yeah, so for me, this answer comes out to be, what is that, 200 joules or something? But it's just different for every person, so it doesn't matter. Part B, your body's actually 25 to 30% efficient at making this conversion. Repeat A, use a more realistic value for the efficiency. Just change this to like 0.3, say. So then instead of 200, if that's 2 times 0.3, then I get the amount of energy. Oh, wait, sorry. So the energy required for me to do this is 200 joules. Does that make sense? Okay. If my body's 100% efficient, then this is how much energy it takes for me to do this. Everybody okay with that? But if my body is 30% efficient, then how much energy does it take for me to be able to stand up? Yeah, you see it's going to take more. If my car was 100% efficient, right, and that allowed me to get like 100 miles to 1 gallon, right? I don't know. And then we take that same gas and put, whatever, the same kind of gas, put it in someone else's car with the exact same car, but for some reason it's not in tune or something, and theirs is only 80% efficient. Do you see, for them to go the same distance as me, to do the same amount of work, do they need more or less gas? Does it make sense to everyone? They need more gas, right? So we're going to need more energy than 200. So what we're going to say is something like, we're going to say, well, what is efficiency? Efficiency is work out over work in, yes? So work in is equal to work out over efficiency. So that's 200 joules, because that's the work out, over 0.3. Okay, and that's like 20,000 divided by 0.3, so it's around 7,000 or something? No, 7. Is that right? Something like that. So what is 200 divided by 0.3? Ooh, how evil. What is it? Oh, is it 2,000 over 3? Oh, I get you. 2,000 over 3, so it's around, 700, so 666, fine. Oh, good. And we